This question is from GATE 2015, Mechanical Engineering paper, set 1, question number 44. A cantilever beam with flexural rigidity of 200 Newton meter square is loaded as shown in the figure. The deflection in millimeters at the tip of the beam is. So this is the beam that is given. If we try to draw the deflection diagram, the deflection curve of this beam, it will look something like this. The fixed support and slope is 0 at the fixed support and downwards further. But it is going to bend up to 50 mm. So if we let this to be point O and this to be point C, we have till point O, the beam is bending. This being the straight beam, the curve AO at fixed end we consider a point A. The curve AO shows the deflected curve between points A and O, while the deflection curve from O to C will be a straight line. Because the beam is not going to deflect, but it is going to only rotate beyond point O. And that is why the deflection that we need to find here at C, that is delta C, is this total deflection. This is delta C is equal to deflection at point O plus this distance, that is nothing but let it be delta. Now this delta can be found out using this triangle. This is point C. Let this be point B. So using triangle OBC, we know this slope because this slope will be equal to the slope at point O. That is theta O. Using this slope, we can find out delta. That is nothing but distance BC. So let's write it. We have delta C, deflection at point C, is equal to deflection at point O plus delta, which is nothing but BC. Now delta C can be written as delta O plus delta can be found out using theta O times OB. OB is nothing but 50 millimeters. So delta O is nothing but the deflection at free end due to point load at the free end. So the point load here is 500 Newton and span of this small beam will be taken as 50 millimeters instead of the complete length of the beam. So we can write first thing, delta O is equal to point load P into cube of length of the beam divided by 3 into EI. This is the deflection for a cantilever beam at the free end due to a point load at the free end. This is a standard expression, you will have to remember it. Similarly, slope at point O, theta O, is given as PL square by 2EI. So let's substitute in this equation 1. We have delta C, second part, delta C is equal to PL cube by 3EI plus PL square by 2EI into OB. Now because this is 50 mm, we have taken L as 50 mm. Remaining is also 50 mm. So we can say this is L. Hence we'll multiply again with L. Here we can take PL cube by EI common. In the bracket remains 1 by 3 plus 1 by 2. So this is nothing but 5 by 6 into. We will have to put the values. P is given as 500 Newton into. Length is 50 millimeters. So we'll convert this into meters. 50 into 10 to the power minus 3 meters cube divided by EI is given in Newton per meter square. So let's keep it as it is, 200. This comes out to be 2.6042 into 10 to the power minus 4. Remember the unit is meter and we have to write the answer in millimeters. So if we convert this into millimeters, it is equal to, we multiply it with 10 to the power 3. So this becomes 0.2604 millimeters. Let's fill in the answer. So the answer is 0.2604 millimeters. Deflection at the tip is 0.2604 millimeters. To learn more about deflection of beams, you can refer to the NPTEL video Lecture 30 Deflection of Beams 1 from the course lecture series on Strength of Materials. It is by Professor S.K. Bhattacharya. He is from Department of Civil Engineering, IIT Kharagpur. I hope this solution will help you clear your doubt. Thank you.